Ever seen your Python list change unexpectedly? The most common way beginners try to copy a list is actually a hidden trap that can silently corrupt your data. Hey coders, welcome back to our deep dive into Python lists. In part 2, we learned to change, add, append, insert, and remove, pop, del list items. Lists have even more powerful tools. Today we'll explore sorting, reversing, finding information, and crucially, proper list copying to avoid tricky mistakes. Let's head back to the code editor. We've seen how to add and remove. What about organizing the items? Python lists have methods to sort and reverse the list in place. Numbers equals 3, 1, 4, 1, 5, 9, 2. Print original numbers list, numbers. Numbers.sort, sort the list in ascending order. Print after sorting, numbers. The sort method arranges the items in ascending order by default. For numbers, it's from smallest to largest. For strings, it's alphabetical. Fruits equals cherry, banana, apple. Print original fruits list, fruits. Fruits.sort. Print after sorting fruits. See? Alphabetical for strings. What if you want to sort in descending order, largest to smallest, or reverse alphabetical? You can pass an argument reverse equals true to the sort method. Numbers equals 3, 1, 4, 1, 5, 9, 2. Numbers.sort reverse equals true, sort in descending order. Print after sorting descending numbers. It's important to note that sort changes the list in place. It doesn't create a new list. Another useful method is reverse. This simply reverses the current order of the list regardless of the values. My list equals 1, 2, 3, 4, 5. Print original list, my list. My list.reverse, reverse the list in place. Print after reversing my list. Like sort, reverse also modifies the list in place. How do you find the index of a specific item? Use the index method. Fruits equals apple, banana, cherry, banana. Index of banana equals fruits.index banana finds the index of the first banana. Print index of first banana, index of banana. Index returns the index of the first item that matches the value you provide. This will cause an error. Print, trying to find index of grape will cause error. Fruits.index grape. If the item is not found, index raises a value error similar to remove. You get item is not in list. Again, you might want to check with in first if you're unsure if an item exists. What if you want to know how many times an item appears in a list? The count method is perfect for this. Numbers equals 1, 1, 2, 3, 4, 5, 9, 1. Count of 1 equals numbers.count 1. Count of 10 equals numbers.count 10. Print count of 1, count of 1. Print count of 10, count of 10. Count simply returns the number of times the value appears. If it's not in the list at all, it returns 0. This is a very important concept and a common source of bugs for beginners. Let's say you have a list and you want to make a copy of it so you can modify the copy without changing the original. Original list equals 1, 2, 3. This looks like a copy, but it's not a true copy. Alias list equals original list. Print original, original list. Print aliased, alias list. If you do alias list equals original list, you might think you've made a copy. But in Python, this doesn't copy the list's contents. It just makes alias list point to the exact same list in memory as original list. This is called aliasing. What happens if we change an item using aliased list? Original list equals 1, 2, 3. Aliased list equals original list, alias. Aliased list 0 equals 99. Change item in aliased list. Print original after changing aliased original list. Print aliased after changing aliased alias list. Both lists changed because they are the same list. This is usually not what you want if you intend to work on a separate copy. To make a true copy, you need to create a new list object with the same contents. There are a few ways to do this. We saw one in part 1, slicing. Original list equals 1, 2, 3. Method 1, slicing. Sliced copy equals original list : creates a new list containing all items. Print original list. Print sliced copy. Using the full slice creates a brand new list. Now, if we change the sliced copy 0 equals 99, change item in the copy. Print original after changing sliced copy, original list. Print sliced copy after changing sliced copy, sliced copy. Only the copy changed. The original list is untouched. This is the desired behavior for a copy. Two other common ways to make a copy are using the copy method or the list constructor. Original list equals 1, 2, 3. Method 2, using copy method. Method copy equals original list dot copy. Print method copy, method copy. Method 3, using list constructor. Constructor copy equals list original list. Print constructor copy, constructor copy. Both original list.copy and list original list create a new list object. These three methods, slicing, .copy, list, create what's called a shallow copy. For lists containing simple items like numbers or strings, a shallow copy is usually enough. What about deep copies? This is a bit more advanced, but briefly, if you have a list containing other mutable objects like lists inside it, a list of lists, a shallow copy only copies the references to the inner lists, not the inner lists themselves. So changing an inner list in a shallow copy will affect the original. A deep copy from the copy module copies everything, including the inner lists. Most of the time you'll use shallow copies, but keep deep copy in mind for lists of lists. Another common mistake, which often comes up when you start looping through lists, which we'll do in a future video, is trying to add or remove items from a list while you are looping directly over that same list. Example of potential issue. Do not do this usually. My numbers equals 1, 2, 3, 4. For number in my numbers, if number modulo 2 equals 0, my numbers dot remove number, modifying the list we are looping over. Print my numbers can get unexpected results or skip items. Modifying a list while you are iterating over it using a standard for loop can lead to skipped items or unexpected behavior because you're changing the size and indices of the list as you go. A common way to avoid this is to iterate over a copy of the list instead, or create a new list with the items you want to keep. We'll see examples of this when we combine loops and lists later. Great job! We've added more tools to our list management toolbox. You learned how to sort and reverse lists, find the position of items with index, count items with count, and critically, how to make proper copies of lists to avoid unexpected changes due to aliasing. We also briefly touched on common mistakes like modifying while iterating and the difference between shallow and deep copies. We've covered the fundamentals and key operations. Now it's time to put this knowledge to work. In part 4, the final video in this series, we're going to build a simple to-do list manager project using everything we've learned about lists. You get to see how these pieces fit together in a real application. Don't forget to check the description for the key takeaways and code snippets from this lesson. A comprehensive quiz and the coding challenge are all coming in the next video. If you're feeling more confident with list operations now, hit that like button. Subscribe for part 4, where we build the project and unlock all the bonus resources. Let me know in the comments if the copying part made sense. Thanks for watching, and I'll see you in the project video.